Hello, everyone. My name is Kevin Doucette. I work here at Shaw Laboratories. Thank you for giving us your time today, especially post-COVID. We know how frantic everything has been and can be, and trying to maximize the best use of our time. So the time that you give us this evening, we very much appreciate, and it's very valuable. Our webinar tonight is Digital Dentistry: How Clinicians Benefit from a Digital Lab, by myself, Kevin Doucette, and my webinar partner here, Amanda DelaCruz. Just to clear up some transparency before we go any further, I've got covering a lot of duties in the lab as of late with our new laboratory build and everything. So I want to give full credit. Amanda has built this amazing webinar that you're going to see, and she should receive full credit for it. So if we can move forward.
Thanks, Kevin. Let's go.
We're proudly serving the North American dental community for over 75 years. A group of full-service digital, highly experienced in fixed, removable, and ortho products. We have 5 locations: Brampton, Kingston, London, and Ontario. Next slide, please, Amanda. About the speakers. Myself, I'm going to go a little reverse history here. I started my career at Shaw Laboratories. I spent the first 10 years honing my technical skills at Shaw Laboratories. And then I moved out into practice on my own for 26 years. Through those years, I gathered a bit of different experience. I spent some time as the president of the College of Dental Technologists of Ontario, as well as a past professor at George Brown. I was a key opinion leader, a KOL for Dentsply, did a lot of consulting work for them. Amanda, our webinar partner here, Amanda is an award-winning designer with a Bachelor of Design from OCAD University and an advanced dental diploma with honors in dental technology from George Brown College. She has been on the dental board of Program Advisory Council for George Brown College since 2015, has been involved with numerous CAD/CAM technologies over the past 12 years. She is currently the CAD/CAM supervisor and has been at Shaw Lab Group headquarters in Toronto since 2013. Amanda is our top designer and our top go-to person in the department. She is a great source for anybody phoning in, needing to ask questions. Amanda is always there to help. Next slide, please, Amanda. A history, Shaw Laboratories has a history of 75 years of leading technological advancements. Our digital workflow, our digital teamwork partnerships, how our expertise benefit your practice, where we are now, and where we believe we will go. And at the end, we'll have a question and answer period. Please feel free to send questions in as we go. But we'll spend some time at the end of this actually answering the questions. Next slide, please. Shaw Laboratories has always been a leader in dental technology. We were the purveyor for many, many years of the first source for fixed restorations, gold crowns, porcelain to gold, and semi-precious. And then when the advent of porcelain to non-precious came about, Shaw was the sole source for that product as well. Next slide, please, Amanda. We were also brought cosmetic dentistry to the Canadian market, the Ontario market in particular. That started with a product by the name of Chameleon Veneers, which was the first generation. Then we moved on to that product, changed into Fortress Veneers. Then all the other products in the market that you see now followed from that. Empress, IPS Empress. We've always been here as a great source for these products. We do our mock-ups for you. We can do case planning. This is a great product source. Next slide, please, Amanda. Full ceramic crowns, Fortress, Imprex, Emax. These are all can be mixed and matched depending on the need of the case. Next case, Amanda, please. Next slide. Also, casting. Shaw's for many years was the sole source of Vitalium casting in Ontario. We did casting and cast partials for most of the laboratories across Canada. Thank you. Next slide, Amanda. Now we're in the realm, we're doing our zirconia in-house milling, milled blue block. The variety of products and expertise that we bring to today's market is really unprecedented in Ontario. And by using us as a partner and a resource, we can really, really help your practice there. Next slide, Amanda.
Okay. Hi, everybody. So I'm Amanda. I'm going to break down the digital workflow for everybody for our CAD/CAM department here at Shaw Lab Group in Toronto. I've worked here at Shaw for over 7 years, and honestly, I've learned something new every single day. We work with some amazing technology here. We live and breathe it every day. And because of it, there's so many possibilities. So we're never bored, that's for sure. I feel very fortunate that we've grown such a great team here in the years that I've been here. Everybody is, so helpful. They're very collaborative. We learn from each other all the time. So sometimes we're really, really crazy busy, but we do have a lot of fun and we have a lot of laughs. So it does make Shaw a great place to work. And we always encourage the dentists to visit the lab and see how we do things. And I'm sure you might want to visit after you see our workflow. So the digital process can be a bit of a mystery if you haven't visited our lab before. CAD/CAM is so broad, it's actually very hard to distill it into a few steps. But there are essentially 6 stages that a digital case has to go through in order to be a finished product and get back to the dentist and the patient. The first stage is scan, the second is design, the third is output, the fourth is manufacture, the fifth is post-process, and the sixth is finish. If you're curious about the picture on the left, it's a batch of digital night guards that we produced about 2 weeks ago in our very accurate, very cool carbon printer. And if you're curious about what stage it's at stage 4. So we'll go to the next slide. So as I said, the first stage is scan. In order to work with the case digitally, we do need to have it in a digital format in some way. So if you're still doing PBS or alginate impressions, we do need a desktop scanner to import that information into a digital format. If you have mock-ups, if you have pre-op models, old dentures, bite blocks, anything that you want us to reference in the final restoration, we do need to use our desktop scanners to capture that data. Here at Shaw GTA, we have a lot of scanners to do all these things. We have a dental wing scanner, we have a Medit scanner, we have multiple E and D series scanners from 3Shape. We also have a Nova BioCare LS3 scanner that's also produced with Cavo. So our scanners are very high tech, accurate to 4 microns. Some pick up color and texture, some can take whole articulators. So we do have our team choosing which scanner to use according to the complexity of the case. If you're already on the digital train, then you're already doing intraoral scanning. We do accept all these scan types that I've listed here. If a new one comes out next month, we're going to accept that one too. Also, if you're having issues sending scans through your portal, you can always export that scan out and send it to us. You can always give us a call and troubleshoot with us. It's not a problem. So we do create our restorations based off of these intraoral scans. It's the best way, it's the most accurate. If we can't, we do produce our models in-house, and then we can convert those produced models back into a digital format to work off, just in case the bite is off and we have to check it, or if we have to reduce the prep or reduce the opposing. Those are the times that we would bring it back in after printing it. So yeah, and if you did want to get an intraoral scanner, please don't hesitate to call. I love helping out the practices. We see thousands of scans a year. We really do know what's good to work with, what's the most stable, what's the most accurate, what might be good for your practice. It's not, there's no standard answer. So I wouldn't just say, it's always this type that you should use. Some practices do more crown and bridge, some do more implants. So there really is, there might be a different need for each practice. So please don't hesitate to call. We'd love to help and make sure that you have a really easy experience. So I just want to share this quote with everybody. I saw it a couple weeks ago when I was putting the presentation together. It's design is not just what it looks like and what it feels like. Design is how it works, by Steve Jobs. When I saw this quote, I was really thinking about our designers in CAD. I used to be a jeweler myself, and as a jeweler, I really just thought about aesthetics, you know, how beautiful it was, how shiny it was, how pleasing to the eye. And I didn't have to worry about function so much. So when I shifted my sights into dental technology, instead I had to bring function up that ladder of importance. And it was, you know, it's really number one when we're working. You know, what's the point of a pretty crown if it doesn't seat, or if the occlusion's too high and you have to grind it? So when we do design, we are thinking of so many considerations at the same time. It's not just plopping a crown in and it'll work well. So we joke about the design process all the time with my lab manager. He tells us that, you know, it should only take a second. There's like an auto design function in the software. You should just drop it and it should be good. And it's funny, and we always joke about it, but I would never do that, because there's so much thought in what we do on fit and function, and it's a skill set that's not mastered so easily. So when I evaluate cases, it's very clear when someone is keeping these considerations in mind or not. So in this next slide, I'm going to go over design. I'm going to show a short video here, just a fast on-screen videos of like some of our designers working. So here we're just doing some festooning and building up the denture, making sure that any red areas which are below minimum thickness are going to be the right thickness for printing and stability. And then we have a night guard here, a digital night guard. Vanessa here was doing the same thing, making sure that it's strong enough, so anything below red. She's also making sure that the occlusal contacts are even, so that when it goes into excursions, we're not putting excess pressure like on the night guard or in the mouth. And the next one we have is a titanium custom abutment. So when we do custom abutments, there's a lot of thought as well. We're trying to make like the most ideal substructure, trying to put an ideal emergence profile, being subgingival, 1 millimeter, making sure it's the right height, anti-rotational. There's a lot of considerations when we do that. You know, you want to make sure it's very, very strong. When we design, there is also that issue of that we're working with manufacturing parameters. So, you know, you might want to make it more tapered or more sharp or narrower, and the manufacturer doesn't allow it because it's too thin to produce in a stable way, and that it's going to last and, you know, be covered under the warranty. So we always have those considerations in mind. And the last design that we have here is a screw retained crown that I was working on. So you can see we're just making sure we don't have excess pressure on the tissue, that you know, we have ideal interproximal contacts, that we are tucking in like the height of contour and making sure it works well with the mouth and the adjacent teeth. So there's just a lot of things to think about when you're designing. And designing is my favorite part. It's the most fun part to me. And, you know, you can turn something from nothing into something. So it's pretty amazing. So when I first started back at Shaw in 2013, I started in the CAD department actually. And we were only doing full zirconia crowns and copings. And then we were also doing a lot of wax crowns that we were turning into casted metal or pressed EMAX. So now when you fast forward 7 years, now in 2020, you can see the list on the right, which I have so many different things that we do with CAD for design. And, you know, if you wait another month, like I said, with the intraoral scanners, like, you know, there's going to be more products. I might have even forgotten some, but we do produce lots of different kinds. So models, implants, snap-on smiles, full zirconia implant bridges, you know, night guards. We have basically anything can be designed in CAD, and that's where the future is going. So the next stage is output. Oops. All right, let's go back. Okay, went too far. Okay, so the next stage is output. That's when we use the computer to help us produce the product. So the computer is turning that digital design into a physical object. Here we have that screw retained crown. Let me play that here. We have the screw retained crown from the last video that we're putting in our CAM software Millbox. And according to the information that we enter, the software will calculate how much bigger to mill the zirconia crown in order to account for shrinkage, as well as which burrs to use, when, how thick of a puck we should be using, how long the machine is going to take to mill it. It's a very sensitive and intelligent process. For example, if I am milling a wax crown, but I put in a zirconia, commands, the burrs will be moving too quickly, and they will be the wrong burrs as well. And because they're moving so quickly, it's going to melt the wax. So it's very sensitive, and it knows how to do everything like to the micron. So it's pretty amazing technology to watch. So manufacturing is the next stage. So at Shaw, we're either milling or we're printing. So this is a stage where digital information finally becomes the physical product. At this location, we have several 5-axis dry mills with automatic tool changers. We use those for wax, temps, and zirconia. And we have 2 4-axis wet mills for our glass ceramics for Emax and Suprinity. We also have 2 huge Stratasys 3D printers that use fused deposition modeling. We print in multiple materials and colors simultaneously. That's where we print our surgical guides, all our removable models. We also have my personal favorite on the right, the carbon printer, which uses digital light synthesis, and it's because it's so accurate. We use it for our implants and crown and bridge models. We use it for our night guards, our dentures, and our soft tissue. So then the next stage is post-processing. So many digital materials need another step before the material is fully stable and biocompatible. So zirconia needs to sinter overnight, and glass ceramics need to crystallize in a furnace in order to showcase their material, their translucency, the proper shade, the optimum strength. For dentures, the carded denture teeth need to be fused onto the printed denture base by hand, and then they're light cured in order to successfully bond the 2 materials. And then models, soft tissue, and night guards from our carbon printer, they do need to be cleaned with alcohol in an orbital shaker, and they need about 2 to 30 minutes in the light cure machine to be usable. Now we've come to the last stage, which is finish. So depending on the product, some assembly may be required. So with the PPE, you would be just assembling the face shield, putting on the foam and the shield itself. For surgical guides, you have to put the pins and the sleeves. With layered cases, then you're layering porcelain. For full Emax, full zirconia, you're adding stain for characterization. If you're doing dentures and if you're doing night guards, then you're grinding in the bite, you're polishing it, you're finishing it off. So in a nutshell, that was the digital process. I really could have just talked about one part of that, and it could have been a whole webinar. There's so much to do. It's so broad, and CAD is really, it's all parts of dental technology now. It's not just crown and bridge. So if you are interested in more things, please let us know. We can talk about it for a while. So the real question is, why would you go digital with Shaw Lab Group? And I think if you asked anybody why they started going digital, the main 2 reasons would be speed. So it's not just that you are saving time shipping, but we at the lab here, we do a lot of things at the same time. So now when you send a digital scan, we can be scheduling it downstairs, and then upstairs someone's modeling and designing the crown already. Overnight, someone is, the mill is printing, sorry, the mill is sintering the zirconia, and beside the mill, the printer is running and building in slices the models. And then the next day you're trimming and staining, and you're completing the whole case. So you're really automating a lot of things. You can work with multiple stages, you can skip stages in some cases. So for example, the wet mill that we have in this slide, the wet mill has eliminated pressing, investing, divesting for Emax. So we basically cut out a day of labor, and we were able to just use our glass ceramic blocks, and then we could crystallize it in about half an hour, and then someone can build up porcelain on it or just stain it, and it's ready to go. So we do offer credit a day because of the technology that the wet mills have provided us. There are also some intraoral scanners that are so fast in their output that they allow chairside feedback from the lab. So there is a few that do that. They also do shade matching through the software. It just saves you a lot of time, and I find that it's very accurate as well. So the patient can still be sitting in the chair, and we can have one of our technicians check your scan for occlusal clearance or marginal clarity, even draw. So it really is a great option when you're first starting out with a digital scanner. The next stage, I don't think anyone can really deny how accurate CAD/CAM can be. So the accuracy involved in scanning, designing, milling, and printing really helps us to standardize our products and repeat our successes. We can analyze distortion between CBCTs and models. We can map nerves. We can measure distances. We can customize our products for fit and strength. We can print a model over and over and over again, and we can trust it every time. We have scanners that I said are accurate to 4 microns. Some of them take like 16 seconds to scan a full arch. Our carbon models are accurate to plus or minus 200 microns. If you tell us to close the bite by 2 millimeters, we're closing it by exactly 2 millimeters. So that is where precision is not so great. You may say 2 millimeters, but it really is like 1.7 millimeters, and that 0.3 millimeters would make a big difference. But because we were given that instruction, it's going to be exactly 2 millimeters. So that's the only drawback I would say, that sometimes it's too accurate in that sense. Another huge thing going for digital, and I think for me is like the major perk of going digital, are the materials that are available now in the digital market. There's a constant desire for innovation in the field to make the product stronger, more aesthetic, more preferable to the patient. So as a jeweler, I loved the idea of milled gold crowns. No more casting, no more porosity, no worries about expansion and contraction, whether there's too much humidity in the air or if the water was too warm when you were investing it. So with milled crowns, you're bound to have a better fit and improved consistency. So we were beta testers when Argan Canada first introduced milled gold crowns. So right now they have milled alloys with 2%, 40%, 58% yellow gold. So I was very skeptical because my jeweler's eyes are very partial to warm yellow gold. I like 18 karat, 20 karat, 22. So I was really not expecting a warm yellow color coming out of a 2% alloy. You know, so I was very skeptical waiting for it to come in. And then when it came in, I was surprised to see that it was very nice. The milling process was so smooth and it was like very well done. I worked in the metal department for a couple months when I was first out of school, and I know how hard it is to make a gold crown look amazing. And with this new material, you're able to get there in half the time. So it's great overall. It's great for your patient as well. In metal, we also have selective laser melting for our R.D.Ts and our frameworks. So it's another way to eliminate the casting and the inaccuracies that can happen in casting. In removables, we have body activated materials such as the Lucitone denture base by Dentsply and carbon that responds to your body's temperature when worn to resist breakage. Dentsply has also released a really nice monoblock resin for the denture try-ins. So you have an alternative to that base plate, carded teeth, and wax setup that is more stable than traditional methods and more similar to how the final denture will fit and feel. Zirconia, Emax, and PMMA, now they come in pre-shaded multi-layer blocks and pucks, which is great when there's a need for occlusal adjustments. Since the shade is embedded throughout the material, you don't have to risk completely removing a layer of color. It really is all the way through. And key splint is another material that we use for our digital night guards now. It's in flexibility, it's in between a hard acrylic night guard and a thermoplastic night guard, the standard ones that we already use. So it's another option if you want something in between. It's also very flexible and stain, fracture, and abrasion resistant. And it is used in our carbon printer, so it is going to be like high quality, very accurate. So we've embraced all these new materials at Shaw, but we don't just jump on every new material or machine that comes out on the market. We like working with validated workflows, meaning that we're not interested in using off-market products. So the printers that we use accept certain materials that are for certain restorations in Canada, and they're very heavily tested. They're also tracked for consistency and quality, because to us, it's not always about flexibility and just getting the cheapest material that will get the work done. We want to trust in that workflow, and we want you to trust in it as well. So we don't just jump on every material that's out there. We do pick and choose what we think will be best for your practice. Okay, so once in a while, my lab manager comes up to me and he asks me if it's possible to do something that we've never done before, something he saw on YouTube or another lab, something just totally brand new. So most of the time I can confidently tell him that we can make it work because I know we can. So we have so many different technologies and materials at this lab that we're pretty confident that there's something we can, if there's a way to do something, that we can figure out a way to do it here. Normally what we're doing is just a variance of something that we're doing all the time. So for example, we have many sintering ovens that you can see on the right of the slide. And so we're almost never limited in how many zirconia restorations we can do in a day, or how many different types of zirconia we might have to sinter overnight. So if you're doing like large restorations that need a longer cycle, then it's not a problem. And we have some that might need a different temperature. So we just are able to handle like all different kinds of restorations. Same thing with our printers. Because we have two huge printers and we have the carbon printer, we're really able to handle all the different kinds of models and needs that the lab has. So we're never limited in that sense. And because of COVID, we had the opportunity to create PPE, such as face shields and Bellus 3D masks that you can see on the left for the medical professionals that were very in need of it at the time. And we had a lot of materials to test on hand and see what would be best for our products. It was just like another thing that we could offer, and like our printer's not going to say no if it's a digital file. Like we can figure out how to print it. So just another example of our adaptability, we printed several ear savers that go on the back of your head to make sure that mask is not hurting the back of your ears. And I wore one of them myself one day, and I just hated it so much because it's just pushing on my nose, because I have a lot of hair, though you can't tell. And I just thought that, you know, we need something bigger for people like me, people who might have bigger heads or wear turbans, all those things that we have. So I do have CAD experience outside of dental from when I was in design school and when I was a jeweler. So I was able to design ear savers that are made for people like us. So I was able to just customize it, just another customized thing. And you know, my friend runs a medical clinic, and he had some Sikh doctors there, and they were so happy that they could finally wear their masks properly. So they were really struggling before they found out that there was a product like this for them. So we really love doing things like that for our clients. So what I find really beneficial about working digitally is the kind of feedback and communication we can have with the doctors now. Because of the technology, we can overlay numerous scans and designs to reference before we continue fabricating the product. So in this instance here, we can directly reference the pre-op condition in order to create a digital mock-up. Then I just shoot a quick email to the doctor with screenshots for approval, and then we can continue with the case planning process. Because the files are digitally saved, we can easily refer to old cases, check settings for spacer and materials, as well as how something was designed. We have a very experienced and diverse team here at Shaw to draw upon for case planning. We have over 37 R.D.Ts. We have people who studied animation, art and design, denturists, foreign trained dentists. I think it's safe to say that you're in good hands here to trust us with your case planning. And because we're so collaborative, we're so team oriented, if the person you reach out to on the phone doesn't know the answer, I would say they'd definitely be able to find somebody who could help you very, very quickly. So I'm going to hand the presentation back over to Kevin to discuss the case planning process more in detail, as well as our future plans for Shaw.
Thank you, Amanda. That was very well done, very informative. As you can see from all that information that Amanda has put in front of you in that short period of time, case planning is integral for success here. And we do in the CAD department understand how overwhelming these choices can be, because there's so many variations now that we can bring forth and bring to bear in the case plan. That information isn't always, because it's coming on board so fast, it isn't always disseminated out to the dentist as of yet. So one of the great advantages that we have here at Shaw's, whether it's myself or Amanda DelaCruz, Mike Lino, our general manager, Al Lino, our implant specialist, David Moore, our QC specialist, Jeff, our denture specialist, all these people you have met in previous webinars that we do. It's a very collaborative effort. So going forward, what we really need from the dentist to be able to give you a more fulsome plan is to provide us with a set of study models. They can be traditional alginate, which we can then scan, or it can be a scan. Give us your alginates, give us a scan, give us a bite, and then give us an overall direction of where you're hoping to go with the treatment plan. And from there, we can break it down, reverse engineer, and really give you a step-by-step, material by material choice of what's applicable, excuse me, for that particular situation. I know from personal experience that the clinicians who choose this route to go through the case planning stage have a much higher case acceptance. Even the presentation now back to your patient is a much more direct, conclusive type of plan that's generally accepted a lot better. Next slide, please, Amanda. So you can see here, this is a case in particular that we went through in case planning. The doctor wanted to particularly open up the VDO on the patient, enlarge the patient's clinical crowns. We went through this particular design in 4 or 5 different stages. We decided mutually on a material that would suit best. We did a number of appointments at the doctor's offices, photos, bites, and this is the finished result on the model. You can see just from the level of detail in here, how much goes into this work, and generally it's very, very successful when we all work together as a team on that case plan. Next slide, please. So now to get back to all of our partners, as Amanda alluded to, we stay within systems. We don't use aftermarket products in any way, shape, or form. We don't use untested materials. All the materials that we have here at Shaw Laboratories that we offer to our dentists are approved, Health Canada approved, and come through one of our trusted partners. We work with Implant Direct, B.Des, the University of Toronto. We regularly have prosthodontic students and dental students in the laboratory from the University of Toronto, as well as we see a great many of their patients here. The Stratasys printers, Stroman, Core 3D, Henry Schein, Evident, Dentsply Sirona, Carbon, Nobel Biocare, BioHorizon, IO, Argent. We have developed partnerships with all of the major players within the industry today to be able to bring a very fulsome and thorough set of products and prosthetics forward to you so that you can offer them safely to your patient. Next slide, please, Amanda. Sorry about that. What's next? What is next? What's coming up next? Well, there are so many things, and Amanda touched base on a lot of them in her part of the seminar in regards to milled alloys, where we're going with denture work. It's really starting to hit a critical mass stage of what's coming on down the road as far as materials. That's constantly changing. With those changes comes changes for us physically as a laboratory. Because basically laboratories up until this point in time have been based on an analog design, right? We were always receiving impressions, algin impressions, sweat impressions, polysiloxane vinyl. The case comes into the laboratory, has to be disinfected, handled, cataloged, make its way through our plaster department, poured, pinned, based, get prepped before we can start working on. What's really transpiring now is very much a paradigm shift on how we handle work coming into a laboratory. I'm very pleased to be able to announce at this webinar a development that we've been working on here at Shaw's and planning for a long time. As I said, I started my career here and spent the first 10 years of my career. Next slide, please, Amanda. So with all of these technologies, the training involved, the space involved, as you can see the picture on the left of your screen, the growing pains. We get equipment in from the US, we get equipment in from Europe, we get equipment in from Canada. But, you know, we have to now reverse engineer how we're running fiber optics, the infrastructure that's in place to make these systems work. We're always catching up. So all the management here, the ownership, we've gone forward and we're making a real change in how that happens. Next slide, please, Amanda. Digital ortho department. Now we have a brand new digital ortho department. We're making nice guards. We have the perfect smile department handling all those ortho needs for you. We're basically expanding in leaps and bounds, and it's really kind of next slide, please, Amanda. And this is our CAD department. You can see our rack of designers as you go forward, and the computers and the level of investment that's required to move through these technologies seamlessly, to be able to bring them to your clinic and to your patients. And so in moving forward, we're here to announce also that we're moving to a new location. Next slide, please, Amanda. Now, that's kind of vast. It really kind of shows the overall scale of it. The scale of this facility is probably, well, it is unprecedented in Ontario, probably unprecedented in Canada at this time. We're right now in the process of building a 25,000 square foot laboratory facility to move into the future, to be able to provide those digital services to yourself and your clients, as well as still remain a trusted partner in the analog world, processing all of your impressions. Next slide, please, Amanda. So this is just an overall little bit of a tease of the overview here of a 25,000 square foot facility. We have our support areas all around the peripheral. We have incoming, our service department. We have reception. We have a lecture area. We have a couple of break areas. Next slide, please, Amanda. You can see here, the actual laboratory was developed by myself, Ali Razi, the owner, Mike Lino, laboratory general manager. We consulted with very many experts in the field in going through how to best be able to handle growth of the future. You can see this layout here. It's pretty much laid out in a cell format that we can propagate as we grow, as we need to. As work expands, we drop in another department, another system. Just for example, in this 25,000 square foot facility, alone we have over 20,000 feet of data and fiber optic cable, 700 feet of copper plumbing, 300 feet drains of vents, over 300 feet of gas. This undertaking is very, very large. Next slide, please, Amanda. And we're proud to be able, I'm very proud to be able to be part of it and to announce it here in our webinar this evening. Here again, our support rooms are investing in casting, our polishing and tooth room. Along with our growth, we're modernizing all of our analog facilities as well, so we can still bring you the best of denture work, still bring you the best of analog crown and bridge work. There's no detail that we've kind of left unturned in this design. Next slide, please, Amanda. You can see here our preparatory room alone. You look at those measurements on the wall, it's, you know, two 22-foot plaster benches to be able to accommodate the level of work that we normally experience. Next slide, please, Amanda. Here we have two ultra-silent compressors. That's a 600-gallon air tank to keep the compressed air lines full. Both those compressors will fill that tank. The tank will keep the line full. I'm pointing out this picture in particular because I know all you clinicians had a hand in building your own clinic and understand the importance of compressed air. Next slide, please, Amanda. Here we have, we were installing, putting in our ultra-modern benches, clean work surfaces. With what has transpired in 2020 with COVID, we are really sparing no expense to develop a facility that will be designed, able not to be shut down no matter really what comes forward for us. And with all the investment that you as clinicians have put in PPE and isolation in your clinics, we want to be able there to support you as well. Next slide, please, Amanda. This right here, it doesn't look like much right now, but this is actually when we're finished in not too distant future. That'll be the first COVID-19 compliant lecture room in all of Ontario, in all of Canada. We'll be able to safely seat 60 participants in there at 6 feet apart. Won't be an issue. It's a real honor for Amanda and I to be able to have this as part of our webinar to bring forth to you and announce. Next slide, please, Amanda. There we go. And in part of one of our break rooms, our technicians work very hard, work very diligently to try to bring great products, great skill, great craftsmanship. So one of our rooms, this being an ultra-modern facility, we're going to have a break room. As you can see on here, we have a foosball table with our values, our mission. Next slide, please, Amanda. So that brought us to the end of our seminar. We'll get to the Q&A in a minute, but I'd like to be able to present our next upcoming webinar, Digital Impressions with Dr. Anderson, Improved Communication with Your Laboratory. This again will be a 1-hour live webinar followed by a Q&A presented by Dr. Phil Anderson, hosted by Shaw and Henry Schein. The course outline will be superior accuracy and fit with digital models, communication with the lab, communication with patients, clear aligners in ortho, and implant digital impressions. This is our next upcoming seminar. I believe this will be in 4 weeks, 2 weeks or 4 weeks. I apologize for that. And now I guess we'll move on to the Q&A. Amanda, would you like to rejoin me here?
Hi. You know, actually we had a poll and I forgot to put it. So I was interested in how many of the doctors have intraoral scanners already, and how many of them are actually using it. So you can answer it whenever you want. And we also have our question period. So if you have any questions now, please write them in and then we'll answer them.
How long, well, the one question here we have, how long does a typical crown take to design after it has been scanned? Well, first of all, I'll say no crown is typical. They're all each individually designed. But depending on if it's strictly replacing a molar or a bicuspid, you're probably looking at somewhere, just for the design aspect, 15 minutes, 15 or 20 minutes. It could be as quick as 12. It could be as much as 20 if there was some special circumstances to have. Your take on that, Amanda?
Yeah, so it really depends on the designer and how much experience they have. So some people are very quick. So I would say that I'm more on the quick side of designing, but I have a lot more experience. We really design like thousands and thousands of crowns in a year. Some people take a bit more time. The implants take longer, anteriors take longer. So it's anywhere between maybe 10 to 20 minutes, depending on the complexity of the case and who's doing them. So it could really be different all the time. And yeah, it's true what Kevin said, that there's no typical crown. We don't really have like a standard that we always see. Yeah. So we have some more questions.
Second question, does Shaw offer chrome guided or similar guided surgery options?
So we do, we work with some other groups that do guided surgery, but there's a surgeon involved and they're going through a course. So we do offer guided surgery options if you have gone through that course and you're very comfortable with the surgeries. We don't recommend it if it's your first time doing guided surgery. So it is something that we can do. So you saw the slides that I had earlier. You saw where we were mapping nerves and we were measuring distances. That was like a software that does do guided surgery for us. So it is something that we can offer, but we do recommend that you are doing a course or you've already done a course. And then this is from Ali. Ali says he wants to publicly thank us and everyone else who worked on it. So thank you, Ali. I have 2 more questions here.
It was a pleasure. And like I said early on, Amanda really did most of the work. She did an amazing job on this as well.
Thank you. Thank you. I have two more questions here. So one is, what troubleshooting tips do you have for intraoral impressions? So as I said, we see thousands of intraoral scans in a year. So we do see a lot of patterns in the types of scans we're getting back. So it's not always relative to what scanner you have, but it's the process of it. So what I've noticed when we have issues, it might be when someone is moving too quickly in the scan. So sometimes they're moving so fast, it's almost like a panoramic photo. So when you're moving so quickly that it starts stretching. So sometimes we see that, and then you'll start seeing, if you printed those models and then you printed it, and then you also scanned it slower, you'll see that the arch is actually wider in the one that was that had went too quickly. So I do recommend that you kind of slow it down. I know some offices are like, oh, we're trying to like go as fast as we can because the technology is so fast, but actually you want to make sure that it's going at the right pace and that it's stitching together properly. So that's something that might not be so obvious until you've done it a couple times. And it also might be a reason why you might have holes in your scans. It might not have a chance to capture interproximally, and that's why we end up having holes. So we do have a lot of troubleshooting here at Shaw. We have a lot of our technicians who are like really good at CAD, and they can try to make it work, but we don't recommend going so quickly. Another troubleshooting tip I have is like a big problem that we have sometimes is that the margins are not so clear. So I do really recommend that the doctors use retraction cord so that the margins are super crisp and clear and the tissue is not impinging on the margin. And also make sure that the mouth, like that area is very dry and you suction out all the blood and saliva. All these things are factors that will affect the fit of the crowns. So in the beginning, there's a learning curve. So we do recommend, if you're just starting to have an intraoral scanner, that you also send PBS impressions so that you can compare and see the fit. And I find that you learn a lot that way, and you can see like some issues we might have. So with PBS impressions, sometimes the impression material itself is pushing the tissue away from the margin. So something that might have been okay with a PBS impression is less okay with a digital impression, just because there's no compression at all, right? So it's just leaving that tissue in place, and it might not be so clear to us. Another thing with troubleshooting intraoral impressions, I would say if you're doing any crowns with partials on top, I would definitely try to do a pre-op scan beforehand. The patient's already in the seat. That way you have that as a reference, and then we can also work with the R.D.T if you bring it in, or whatever we need to do, but it's always good to have that there for us to reference. So that's my troubleshooting tips for intraoral scans. Go ahead.
Yeah, I'd just like to, Amanda really hit the nail on the head there. The same issues that will give you a problem in an analog impression will give you a problem in a scanned impression. Pacing is important. Going too quickly, even though the manufacturer tells you you can do a full arch scan in 30 seconds, or the computer stitches the image together, right? It takes, as you pass back and forth over the ridge, it stitches all of that information from what it's passed over. The faster that you go, the less accurate that the stitching is. Retraction cord, having a clean site before you take a PVS or before you take a scan is critical. I mean, it's kind of hard. That's a hard phone call for Amanda and I to take, because we know how much you've invested, a doctor has invested in their scanning system. And when we're not seeing accurate margins, and we see that it hasn't been corded, it's the same answer. It's no easier. It's no easier for us to tell or to ask a dentist to please take another scan than it is easier for us to ask a dentist to take another impression. So it's really about either pre-scan or pre-impression, right? Good planning makes for a good result.
So we have another question here. What's the longest span of bridge that can be scanned? I don't believe that there is a limitation there. We've done full arch cases and we haven't had any problems. I do know there's some older scanners, you probably don't have them now, but some of them were better for quadrant impressions. And you would probably know that if you had the scanner already, that they're more accurate when they're smaller, but the newer scanners tend to be fine. So I wouldn't say that there's a limit in the span of bridge. But again, if you're doing like a big restoration, try to take the pre-op scans as well, just for reference. It's good to, so we have the buccal contour and everything and have as many things helping the designer as possible.
And really, sorry to interrupt, Amanda, but really, it's not you can scan a full palate, right? You can scan for a denture. You can scan all that information. The question is material choice. When you're doing a large bridge, you have to take into certain facts that zirconia, you can only really, or should be only really hanging 2 to 3 pontics between 2 abutments. Just because you can scan something or impress something doesn't necessarily mean we can make it in your material of choice. We still have to, there are limitations on all material choices, and we may have to have a discussion based on that choice.
And then I have a question about zirconia crowns. What kind of preparation is needed for a zirconia crown, and how much occlusal clearance do you need? So I would say sometimes we do get knife edge margins for our zirconia crowns. I would not recommend it at all. Zirconia does require a chamfer margin, so the more that you can do that, the better that your finish will be. The margins will be sealed. They won't. They're just meant to be a little bit thicker at the margin, so we don't recommend doing knife edge. Also, we do work with our zirconia to have its maximum strength. We like to have 0.6 millimeters in zirconia. So that doesn't include the cement. It doesn't include like occlusal clearance. So I would say like 0.8, 0.9 millimeters is the minimum if you want to go with the zirconia restoration and you don't want to reduce the opposing or anything.